Okay, so we're doing section 1.5 in the book today. It's a library of functions. Today we're going to do the functions that you learned in Algebra 2 or before, and then tomorrow we're going to do new functions that you probably haven't done before. So we're going to do 1.5 in 2 days. Functions are equations that can be written in the form y equals. They would be functions you could solve y equals. And because they are solved for y equals and they're functions, we give them a fancy symbol. Instead of y equals, we write f of x. Right here, f of x equals, which is read f of x and means the value of the function when you input the given x. F of x is the value of the function at that particular x. So I'm using the word input. That leads us to domain and range of a function. Heard of domain and range before? Okay. So the domain, does anybody remember anything about domain? X values, yeah. I'm going to start by saying it's the input. And then usually we input the x values. And then if we are looking at a graph, the inputs or the x values would be the left to right. How far it goes to the left and how far it goes to the right and everything in between. So then we look at the definition for the domain of the function, and then we fill out the definition of the range of the function. The range would be the output. So you put in an x and you get out the y values. And then when we graph them, the y's are always down to up. And I chose to say that in the order of down to up because we want to start with the most negative numbers first and work our way to the most positive. We have been doing linear for the past few days. We'll start with that one. The linear function is f of x equals mx plus b. So when we have a function, we can solve it so it says y equals, and then we replace that y with f of x. So that's why this one says f of x equals mx plus b. And we already know m and b are, we know this stuff already. Okay. So the domain, so we have a line, could be any line. The domain is how far to the left and how far to the right this line goes. What do you think? Excellent. So you are giving me the interval notation that is negative infinity to positive infinity. Some of us learned it last year. Some of us did not learn interval notation. So I'm going to take a day and teach it. For now, we're just going to talk about wording-wise. It is all real numbers. Okay? There is an abbreviation for all real numbers for those of us that can't possibly write all that out. That's way too much, I know. So you could write it as the correct symbol for all real numbers is a big capital R with like a double line. That means all real numbers. Not yet. Please don't do the interval notation yet. We will do that together. For now, we're doing just the words. All right, range. I've got my line right here, and the range is from down to up. How far? All real numbers. It's going to go all the way down to negative infinity, all the way up to positive infinity. Doesn't stop. So all real numbers. Or you can write that symbol. You should know an intercept when you see y equals mx plus b or f of x equals mx plus b. What intercept is it? The y-intercept, yeah. 0, b. There is an x-intercept. We're not going to write that down right now, but there is one. Then the behavior of the graph. So the behavior of the graph always has to do with when you look at your graph, left to right, just like you read left to right. What are the y values doing? What is the function doing as you go left to right? So going left to right is the x's. You answer your question about the y's. So when I have a line, left to right, what are my y's doing? Always? Are they always increasing? What's going to determine if they're increasing or decreasing? The slope, the m, right. So we're gonna have like a couple situations. So if m is greater than 0, the y's are increasing. And then if m is less than 0, the y's are decreasing. So if m is greater than 0, it's going up. If m is less than 0, it's going down. What if m is equal to 0? Horizontal, right? What is that called? Does anybody know? It starts with C. Constant. Good. The y's are constant. Maybe look, what's coming next? There are two special types of linear functions. The first one is the constant function. So if we have a constant function, we're going to have f of x is equal to c, and c is some constant. It is just a number. It's not c, it's some number. And there's a picture, it's kind of off to the side on your notes. There's a picture of an example of a constant function. You see it's a horizontal line. And the constant function is special. The domain of this, it's special that I'm writing the domain and range for it. It's special. Domain is left to right. Well, how far does it go left to right? That one's all real numbers. That one's not special. It's the range that's special. So the range of this one, we're talking about the lowest number to the highest number. We're talking about the y values. So if you look at this, you look at every single ordered pair that could possibly be on this line. What's the lowest number and what's the highest number? C. I don't know what it is. C. Right? So there's not like a range of numbers. It's just C. So we say, well, y has to equal C. That's our only option for the range. And then the identity function is f of x is equal to x. It's identity because the y, the f of x, is the same as x. Identity means when they are exactly the same. So here, every single ordered pair, the x and the y are the same number. And then the domain and range are all real numbers for that one, just like all the other linear functions. The equation x equals, I'm just going to pick a number, 2. Is that a function? Not a function. Because function I can write as f of x equals, which is the same thing as writing y. Y equals. Can I write this as y equals? I cannot write it as y equals. This is not a function. Just so you know, it's a line when you graph it, but it's not a function. It's not a linear function. All right, example 1. This is the kind of stuff you'll do in your homework. We're going to write a linear function. Write the linear function f for which f of 1 equals 3 and f of 4 equals 0. Then graph the function. Write the domain and range of the function. So we're going to use these numbers right here. F of 1 equals 3. So far today, we've always been talking about f of what? F of x. This is saying f of x is equal to something. What is f of x equal to normally? F of x is the same thing as y. So this is the same thing as f of x equals y, except for it's f of 1 equals 3. That's telling you x is 1, y is 3. When x is 1, y is 3. That's what it's telling you. So we have an ordered pair, 1, 3. So the second one, f of 4 is equal to 0. F of x is 4 is equal to y, which is 0. So 2 ordered pairs. We have to graph it and find the function. We can graph this really easy. And this says it's linear, so I know that I can just make that a line if I want to. Or we can graph it after we find the function. How do I find a function? I've got 2 points. What should I do? How do we find the equation in the past couple days? 2 points. What should I do? What are you finding? Sorry, what are you finding? Slope. My head. Am I doing it right? Who's in my class? Is that it? Am I doing it right? Does it look bad? Or tight? Where's my pinky go? Up? Down? Does it matter? So we're going to find our slope. 0 minus 3 over 4 minus 1, negative 3 over 3, negative 1. Got my slope. Or I could use my graph and just count rise over run. I could have done that too, I guess. I already graphed it. And then after we find our slope, what are we going to do? Point slope form. Which point should I use? It's a matter of opinion. Which point should I use? Why? What's that say? Did you say that? Why? Right. Well, kind of, yeah. It's already. When I go to plug in a 0, I think it's a lot easier. But it's a matter of opinion. You can use the first one. Some of you are working ahead and already did the first one. So we're going to do point slope form. We'll do y minus, I'm going to use the second one, 0 equals our slope. Negative 1 times x minus 4. And I already have y equals, distribute negative x plus 4. Whoops. And then they want a function. So they don't want y equals. We're doing a function, we're going to write f of x equals, and you just write negative x plus 4. So if they're asking for a function, which is what we're doing today, you're going to have f of x. And then if you wanted to graph it using the equation instead of the ordered pairs, you would start at positive 4 and you would go down 1 over 1. And so on. All right, it does also say in the directions to find the domain and range. So left to right, domain, left to right. What do we have? All real numbers. Range, up to down, down to up, I mean. All real numbers. So when you do your assignment, you're going to be answering all those same questions. Make sure you don't skip stuff in the directions. That's not us. Okay, the second part of today is we're going to go through all these functions that you learned last year. Or a lot of functions, not all of them, but a lot of functions you learned last year. Is that you? And we're just going to talk about their parent functions. You remember doing parent functions last year? And then what did you do once you had a parent function? Do you remember what you did with it? Do you remember transformation? Reflections, translate, what else did you do? Stretch and shrink. We'll do that Friday, I believe. Today we're just gonna use tables and talk about the basic shape of the graph. All right, you got your arms warmed up, they're stretched and ready to go. You got to give me a graph with your arms stretched. I mean, I'm not joking about giving you a graph, but you know that stretch. What's absolute value look like? Show me with your arms. What's it look like? It's not a W. They don't move forward. Yes. All right. That's not a W. All right. So absolute value is a V. Absolute value is a V. When you draw an absolute value graph, it better look like a V. So if you draw an absolute value graph and it's just a line, you know you're doing something wrong. Or if you connect it and try to somehow make it look like a U because you've seen U's before, absolute value is a V. We're going to use the same, what are they called? Parent function points. You like have done for years. -2, -1, 0, 1, 2. We're going to plug that in. What's absolute value do? Change to the positive. So we're going to have 2, 1, 0, positive, 1, 2. And we graph those. And when we connect it, we know that it looks like a V. So when we connect it, it's going to look like a V on your paper. And it goes on forever, so even though I stop drawing points, you use your straight edge and keep going. It's okay if you didn't use a straight edge on your notes, just use it in your mind. Okay. The domain, left to right. How far to the left, how far to the right? All of them? All real numbers? All real numbers. The range, we want the lowest point to the highest point. So I ask you, what is the lowest point on the graph? 0. What's the highest point? Infinity. Goes from 0 to infinity. So we're going to write that as the y's are greater than or equal to 0. All the y values start at 0 or go above. The intercept on the graph is 0, 0. And then the behavior of the graph. The behavior as the x's go from left to right. You get in the little roller coaster and it's riding this graph. What's happening right now on your roller coaster? We're going down, and then we get to here, and what happens? It goes back up. So we're going to say the y's increase when the x's go from negative infinity to 0. No, I said increase. I meant decrease. I'm so sorry. Let's try that again. Y's are going down. You even said it, and I don't know why I wrote increase. The y's are decreasing from negative infinity to 0, and then the y's increase when the x goes from 0 to positive infinity. So we are always talking about the behavior of the y's. We're always talking about the output of the graph according to what the input is. Are we okay? Are we hanging on? Are we doing all right? Okay, next one is the quadratic function. Do you remember quadratic function f of x equals x squared? Does anybody remember the shape it looks like? U-shape. This looks like touchdown. U-shape. U-shape. Okay. Well, we'll dance later. And if you would like solos, we can do that too. Sorry. Solo? Oh, she wants a solo? No. I'm going to use -2, -1, 0, 1, 2. And when we square a number, we always get a positive. When you square -2, you get positive 4. And you know it's a U shape. So when you connect it, don't make it look like a V. It should not have a point at the bottom. It should be rounded at the bottom. I see some really good U's out there. You must have practiced last year. So I had a good teacher whip it in there. The behavior of this graph is exactly the same behavior as the previous graph. It's going to go down until we get to 0, and then it's going to go back up. So I'm just going to literally copy word for word what I have over there. Intercept, 0, 0. And then the domain and range. Domain and range, just like the absolute value, goes left to right all the way. So it's going to be all real numbers. And then the range starts at 0, goes all the way up. Y is greater than or equal to 0. Next is cubic. Cubic function. We're going to use same ordered pair or same x's. Same inputs. But when you cube a negative number, -2 cubed is still negative. -8. -1. 0. Then 1. Then 8. Cubic function. The behavior of this graph, or the y increases the whole time. As we go from negative infinity to positive infinity, left to right, the y's increase the whole time. Intercept at 0, 0. Domain, left to right. How far does it go to the left and to the right? Do you know? What numbers am I allowed to plug into x and cube? All of them. You're allowed to cube anything. There's no restrictions. So all real numbers. And then range, bottom to top. How far down does it go? How far up does it go? All real numbers. Good. Okay, next is square root. This is where we're going to start having some limitations. Square root. We're going to make a table. And when you do this stuff in homework, you're going to be given a square root function. It's going to have more than just x. It'll have some other numbers in there. All you have to do is plug numbers into the table and plot what you get out, your input and your output. Just have to plot order pairs. Well, that will be smart about it. What can I not take the square root of? Negatives, right. Okay. You cannot take the square root of a negative number, so I'm not going to put any negative numbers in the x column. Do I want to take the square root of a number like 2? Do I want to? No, because that's a decimal and I don't want to deal with that. So I'm only going to pick numbers that I can take the square root of easily. So what am I going to pick? Can I take the square root of 0? You can. It's 0. Can I take the square root of 1? Can I take the square root of 2? No. What can I take the square root of next? 4. What's next? 9. What about 16? Yeah, but is it going to fit on my graph? So we graph those. So we have this little curve that just starts at 0, 0, 2. So our behavior of the graph is the y's are increasing, but the x's just start at 0 and go into infinity. It's the only part where the x's are. The y's will increase from there. Intercepts, there is one at 0, 0. We put our domain and range. So our domain is what is the left to the right? What is the leftmost number? 0, and then it goes all the way to the right. So our domain is that x is greater than or equal to 0. And then the range, what is the lowest number? 0 to the highest number, infinity. y is greater than or equal to 0. So in your homework, you're going to have other ones that are not the parent function, so you got to like ask yourself, what's the lowest number? It might go down to like -4 or something. I'm giving you easy numbers on the homework. You just have to think about domain and range. All right, last parent function. The reciprocal function. So we're going to pick numbers to go in our chart that we can easily take the reciprocal of. So I'm actually going to put more numbers in this chart than the other ones. I left 5 places. I'm going to put 7 numbers in it. So I'm going to start up here. And I'm going to start with -2. Can I take the reciprocal of -2? What is that? -1/2. And then -1 I can take the reciprocal of. If I flip -1, it's still -1. The next one I'm going to do is -1/2. Just picked an easy fraction that I can take the reciprocal of and I can still graph. What's the reciprocal of -1/2? -2. And then 0 I'm going to do next. If I put 0 in my chart and I take the reciprocal of it, what's the reciprocal of 0? Can I take 0 and put it on the bottom of a fraction? We cannot. So this is going to be undefined. Means you can't graph when x equals 0. Next one I'm going to do is 1/2, and then I'm going to do 1 and then 2. So if I take 1/2 and I reciprocate it, I get 2. Take 1 and reciprocate it, I get 1. Take 2, reciprocate it, 1/2. I'm going to plot those. And it's small. I apologize, the people in the back, small. Even the people in the front, it's still small. You probably did these last year. You had asymptotes. Remember the word asymptote? You've heard of the word asymptote before? Yes. We aren't doing asymptotes yet, but we will. We're just looking for general shape. This one has 2 branches. Domain, left to right. How far does it go to the left? How far does it go to the right? Right, so you right now are telling me interval notation, which is excellent. So it'll be easy if you know interval notation once we do that. I'm going to put it in the other notation that I can't remember the name of right now. I'm just going to write it as according to x. The x's go from -infinity, they go up to 0, but they can't equal to 0. So they're basically everything except for 0. So we're going to write x does not equal 0. It's everything else, but not equal to 0. Some of you may have done that when you did these graphs in Algebra 2. You might have written all real numbers, but not equal to 0, something like that. And then the range. The range goes all the way down. It goes all the way up, but it jumps over 0 also. So for the range, we're going to put y does not equal 0. Intercepts, there are none. And then the behavior of the graph. As we are going from left to right, and we're riding our roller coaster, where are we going? Where are we going? Down. So y is going to decrease. When x goes from -infinity to 0. And then after that, jump way up here, what's y doing now? From 0 to positive infinity. What's y doing? It's also decreasing. So it's also decreasing when x goes from 0 to infinity. So it's decreasing in both sections. Okay, now The rest of the examples are going to be like homework is. All right. The information above was to help you, especially when we do transformations. But this next section, this is what homework's going to be like. You're going to graph it by filling out a table, plotting points, write the domain and range. Okay? So we just want to think about like what points would be good to plug in for x squared plus 2. Are there points that you would prefer? So you can do whatever ones you want, but I would encourage you to kind of look at what we did when we had x squared before. What shape is this going to make? The U shape is going to be a quadratic, it's going to be a parabola. So we know that it should go down and come back up. Depending on the points you pick, you may or may not see that. So you might have to pick more points if you don't see where it goes down and comes back up. Or it could be upside down. How would it go upside down? What would make it go upside down? Shape? In front of the x squared, right? If there was a negative in front of the x squared, it would flip it down. So I'm actually just going to still use -2, -1, 0, 1, 2. Do you remember anything about transformations? What's that +2 going to do to the graph? It's going to move it up too, so it's not even going to move it left to right. So I can use those same x's. It's going to be higher. If you remember last year's stuff. So we have a 6, and we plug this in, get a 3, 2, a 3, and a 6. You should also remember that these are symmetrical. Over the y-axis, side to side, they're going to be symmetrical. And our domain is going to be all real numbers. But now our range, because of that +2, our range is different. So just think about it. What's the lowest number? 2. And then it goes all the way up. So we're going to say that y is greater than or equal to, 2. So with example B, 1 minus x cubed, what would be a good numbers to plug in? We do 1 minus whatever you plugged in cubed. You guys already picked some? Okay, well what I picked was -2, -1, 0, 1, 2. And then you just have to think order of operations. So we're going to put in cubed, and you have to cube it first before you do 1 minus. So when I cube -2, I get -8, so I'm going to do 1 minus -8. So positive 9. And then we're going to do 1 minus -1, so positive 2. 1 minus 0, 1. 1 minus 1, 0. And 1 minus 8, -7. Domain would be all real numbers, and range is all real numbers. Oh, did it not copy all the way down to the bottom? Sorry. I was not aware it didn't copy all the way down to the bottom. Sorry about that. So the next one, we've got a square root. And remember, the square root is the one where you can't like take square root of negative numbers, and you don't want to square root numbers that don't square root nicely. So just think ahead. What's something that we could take the square root of? Remember the parent function chart? We took the square root of 0, 1, 4, 9. So let's make underneath here, let's make it say 0, 1, 4, and 9. How do I make this equal to 0, x plus 4? What should x be? So let's do -4. And then I plug that in, I get 0. I take the square root, I get 0. How can I make it equal to 1? What do I plug in there so it says equals 1? -3. And then how can I make underneath the square root just square root of 4? How can I make it square root of 4? Plug in 0. How can I make it square root of 9? Plug in 5. And how can I make it 16? 12, well, that one doesn't fit on my graph, so I'm not going to do it. Okay. Negative 4. Plot those points. It should look like that general shape of all square roots. If it doesn't, then check your work. And from here, our domain, we're thinking the left to the right. How far does it go to the left? It goes all the way to negative 4, then it goes all the way to the right. So we're going to say x is greater than or equal to negative 4. And then the y values, how far does it go down? 0 all the way up. So y is going to be greater than or equal to 0. Okay, the last one. What kind of shape is that last one going to make? V shape, right. Absolute value is going to make a V shape. So we're going to plug in points that would make sense. I do not remember what I did. I did 0, 1, 2, 3, 4. That's what I did. But you might just have to play around and get whatever points from there. And if you remember transformations, that might help you just pick points a little bit better. Because when you pick these points, you'll see that that vertex point is at 2, negative 3. If you remember transformations at all. And it's okay if you don't totally remember it, because we'll go over it. We look at our domain. Goes all the way to the left, all the way to the right. Domain is all real numbers. But our range, just kidding. Yeah, no, that's right. The range is like a little different. The range is, what's the lowest point? Negative 3, and it goes all the way up. So y is greater than or equal to negative 3. Yes. I know that went fast. But like I said, I'm posting this video. I'm going to put all the notes that we did in class up on Canvas, so if you need to go back and look at it, you can. And we will have study hall tomorrow if you have questions. I will.